Good afternoon, everyone. We are in the midst of some chaotic technical issues at the moment, but they appear to be resolved at least for now. Right before we went live, all of a sudden we lost all connection to my producer in the UK. I'm currently still in South Carolina, so apologize for the problems that have arisen. Hopefully, we will get some of our viewing public back once they become aware of where we are. But in any event, really happy to have you guys here at the moment. So, where is everybody checking in from? First of all, let's go ahead and see where everyone's watching from. Once again, I am here in South Carolina, leaving day after tomorrow to return to the UK, and all because of the viewers, all because of you guys. I put out an appeal in a video that I released just a couple of days ago, and you guys responded in a huge way. Not only is it going to cover my expenses in getting back, it's going to also help me get up to Saxavord. You guys are absolutely fantastic. Thank you so much. We have Birmingham, Northeast England, 4 marks. We have Alabama and Yorkshire, Cheyenne, Wyoming. Hello, Cheyenne. Always very fond of that town. Bristol, UK, Fort Myers, Florida, Oklahoma, Rochester, New York, Las Vegas, New York City. Thank you very much. Hello, Philadelphia. OKC, we got North Yorkshire, Hollywood, California, Wiltshire, UK, Hopkins, Minnesota, and also Virginia checking in. Anton Nim, thank you so much. Really appreciate the $10 PayPal I got from you, Anton Nim. You and a lot of other people, let me tell you, it was the biggest burst of support that I've ever received. You guys have been awesome in getting me back home. I appreciate it. Hello, Portugal, Oregon, Bulgaria, San Francisco, another UK, Oklahoma, Northumberland, Louisiana, Columbia, South Carolina. Hello, just down the road from me. Stockholm, Southwest Germany, Connecticut, Missouri. Thank you very much. I appreciate you guys tuning in today. We're going to be talking about Apophis, a topic that I have talked about a lot. And I'll tell you, it's something that continues to frustrate the hell out of me because NASA ruled out the possibility of this asteroid striking us about 2 years ago. Might have been three, something along those lines. And I would say that I agree that Apophis very likely is not going to impact the Earth. But the margin for error is so small. We're talking this asteroid is going to be passing us within the orbits of our geosynchronous satellites by, astronomical terms. This thing is giving us an unbelievably close shave. And that being the case, it's something that we really need to be paying attention to. And in case anything changes, we need to be ready. Thank you, John. Really appreciate it. Thank you so much for the tenor. Really makes a big difference. All of the support I've been getting lately, tell you, it's made a huge difference in terms of what I'm going to be able to do for you guys here in the near future. So here's the thing. There are 140 users stuck on my other stream, apparently. If that is indeed the case, we need to make sure that that stream is completely shut down. But I'm the producer will take care of that. Thought we had that stream shut down, but I'll tell you, it's been a technical day from hell. It really has. So in any event, here's the thing, because the margin for error is so small. Because if we're even a little bit off on this, it could be cataclysmic. And by cataclysmic, let me try to explain to you just how bad this might be. If we had an impact from an asteroid the size of Apophis, we're talking an asteroid about the height of the Empire State Building and far with a much greater beam, shall we say, if we're talking ship terms. This is something that would create quite an explosion. It would really ruin the day for anybody who happened to be anywhere nearby. And by nearby, I'm talking 100 kilometers or so. We're talking an explosion in excess of 1,200 megatons, thousands and thousands of Hiroshima bombs, and about 23, 24 times as powerful as the Tsar Bomba, the most powerful bomb ever detonated by human civilization. And in addition to that, it's also more powerful than any volcano that has erupted in human history. So the consequences would not only be for the region that it hit. If it were to strike offshore, it would create cataclysmic tsunamis, far more severe than the ones that struck Southeast Asia at the beginning of this century and the ones that struck Japan about 10 years ago. It would be far worse than that. Papsu, thank you so much for the $2. And in addition to that, given the size of the explosion and how much debris would be hurled up into the atmosphere, and also if it were to hit on land, it would create a firestorm roughly 120 kilometers in diameter, far more acreage than the biggest fire in recorded history, like 4 times as big as the biggest fire in recorded history. And that's just just suddenly a firestorm that big would exist. And no doubt it would spread far beyond that. A firestorm of that magnitude, plus all of the soot and debris that would be carried up into the upper atmosphere, would unquestionably create a nuclear winter. Not as severe as some of the cataclysmic nuclear winters that we talk about with planet killing asteroids, but it would have global consequences. And so I've always said that, there are certain things that could happen that would change the trajectory of Apophis ever so slightly. We're not talking about a big change here. A very minuscule change would be necessary, actually, to turn a near miss into a collision. And that is what a recent study that came out on March the 4th of this year, just last month. It has yet to be peer reviewed, but it got the attention of the media. And that's what they decided to talk about. What if there is something that changes the course of Apophis slightly? What might the consequences be? And can we predict that something like that might happen? Well, as it turns out, yes, we can. And there may indeed be a problem here in the near future, even though the media would have us believe that this study says that there's no chance whatsoever that Apophis is going to change its trajectory even slightly. There's no chance that we're in any kind of danger. NASA is right, blah, blah, blah. That's what the media says this study is saying, but they're wrong. The study's not saying that at all. And I'm going to prove that to you here in just a moment. Asteroid 99942 Apophis will pass near the Earth in April of 2029, expected to miss our planet by a safe margin. That could change if Apophis's path was perturbed by a collision with another asteroid in the interim. Though the statistical chance of such a collision is minuscule, the high risk associated with Apophis motivates us to examine even this very unlikely scenario. See, I admit that the odds of Apophis being, on a collision course are very small. It was always very small, but it's not zero. That's the point that I'm trying to make. We should be prepared in the event that it turns out to not be zero, but a lot more possible than we originally thought. In this work, we identify encounters between known asteroids and Apophis up to April of 2029. Here we show that Apophis will encounter the 1,300 meter diameter asteroid 4544 Xanthus in December of 2026. Their minimum orbit intersection is less than 10,000 kilometers from one another, with Xanthus passing the closest point just 4 hours after Apophis. So we're talking a 4-hour margin between these asteroids passing the same exact point in space. And this asteroid, by the way, is over a kilometer in diameter and actually has a gravitational field associated with it. Not a big gravitational field, but once again, you don't have to divert this asteroid very much at all in order to change a near miss into a collision. Hi, Q. Thank you so much for the fiver. This is why NASA has to focus on developing the DART program. Totally correct. We need another DART mission ready to go, poised to go, preferably in orbit or in lunar orbit, perhaps in conjunction with the Lunar Gateway, something that's ready to knock an incoming asteroid off target in an emergency situation. By the way, incidentally, we also found an asteroid that's only a little bit smaller than Apophis. We detected it about 4 days ago, and it just made a close approach. I mean, we detected it less than a week before it passed between the orbit of the moon and Earth. Once again, a considerable distance, a couple 100,000 kilometers, but still ridiculously close in astronomical terms. And we didn't even know that this thing was there until a few days prior to collision. So another big emphasis that we continue to need is the ability to detect these things before this kind of scenario transpires. And by the way, it is amateur astronomers who frequently are the biggest part in detecting all of these things. Okay, so let's go ahead and have a look at this passing body. I'm going to go ahead and just examine it real quick. This particular asteroid. And by the way, we have an animation that you guys can look at as well to determine. So yes, let's go ahead and have a look here. Unique amongst our results of all the asteroids that they studied is a close approach, and you're looking at that video right now, between Apophis and asteroid 4544 Xanthus on December 25th, Christmas Day, 2026. 4544, it talks about its absolute magnitude, and it has a 1.3 kilometer diameter. This is considerably larger than Apophis, about 25 times more massive, assuming a similar density and albedo. The JPL orbit is based on over 1,800 observations over 34 years. So we have a very good understanding of where this asteroid is and where it is likely to go. So it is going to pass Apophis at a distance of 9,604 kilometers on Christmas Day, 2026, with a margin of error of plus or minus 6 kilometers. So it isn't going to pass close enough for a collision, but it is going to pass close enough for its gravitational effect to have a tiny, tiny impact on the trajectory of Apophis. Now, what kind of impact is it going to have? How much is it going to change where it's going? We actually don't know. We don't know enough about the composition of this object. We have estimates, but we really don't know exactly how much of a gravitational influence that this asteroid is going to exert to know how much of an impact it's actually going to have on where Apophis is going. But it's a very, very good reason to keep a close eye on Apophis after December 25th, 2026, to see where it happens to be going after this asteroid has an impact on its trajectory. Again, not big, but at the same time, a 1.3 kilometer diameter asteroid, especially if it were an iron asteroid, for example, it would definitely have at least some impact. I think we had another super chat come in. Just want to make sure that I don't overlook these things. No, that was Hi, Q. Thank you. Would deploying telescopes on the moon give us better coverage about what's coming and going in our solar system? Unquestionably. The best place, however, to put one of these telescopes is in a Lagrange point, a stationary Lagrange point between us and the sun. And the reason that's important is because many, many asteroids are lost to us in the glare of the sunlight. In the glare of our sun, a lot of asteroids, their orbits are are usually consumed by sunlight, and we can't see them at all. We can see them perhaps 2 or 3 days out of the year, and the rest of the year they're orbiting the sun in a position where we can't see them. But if we were to put an observational satellite in a Lagrange point between ourselves and the sun, it would give us the ability to see a lot of these asteroids. Good question, by the way. Let's go ahead but here's another consideration about this object, not just in terms of whether it is going to collide, but rather the impact of the of objects that may be in a trail behind it. You see, asteroids oftentimes have been subject to numerous collisions during their long lifespans. An asteroid, it may go millions of years before an asteroid strikes anything, but oftentimes an asteroid will hit something in the course of its existence. And when it does, when it's a small object that collides with it, say the size of a baseball or maybe a football, something bigger than that, it creates debris. Now, that debris doesn't just go flying off into space. Oftentimes, that debris coalesces around the gravitational pull of the asteroid, especially if it's a relatively large asteroid like Xanthus. And so there could be debris trailing Xanthus as it makes its way around the solar system. So even though, and this is something that is mentioned in the study, even though Xanthus itself may not come into contact with Apophis, some of the debris behind it may come into contact with it. And once again, even a tiny piece of debris, we're talking a couple of centimeters in diameter, could have an impact on the course of this asteroid. Let me go ahead and see if I could yeah, let me go ahead and mention this again. I found the part here in the study where they talk about this. Xanthus could have low-level undetected mass loss, which would make it an active asteroid. There are a handful of active asteroids known, which may release material through an array of mechanisms. Material traveling with Xanthus will be particularly difficult to detect with telescopes. Um, Telescopes on Earth if it is low in dust production, dust having a large optical cross section for its mass. For example, the OSIRIS-REx spacecraft revealed that asteroid 101955 Bennu was surrounded by 1 to 10 centimeter particles ejected from its surface at speeds of a few meters per second. These particles are thought to be ejecta due to meteor impacts, but no dust was reported. Particles were seen to persist for several days in some cases, and some were on trajectories that would allow them to escape Bennu's gravity entirely. It is possible that Xanthus is producing material in this way. The material discovered near Bennu was a surprise, and other mechanisms could produce unsuspected material traveling with almost any asteroid. Now, does this sound like this study is saying that there's absolutely no danger whatsoever of this object ever colliding with Earth, of Apophis deviating on its present trajectory? No, it doesn't sound like that they're saying that at all. Instead, what they're saying is that there's a variety of different factors that we don't fully understand and we have not identified simply because we don't have the observational capability to do so, that may indeed have an impact on the course of Apophis. And so, what is being emphasized in this study, and by the way, this is not the only close encounter either, this is the most significant of close encounters, this Xanthus asteroid, but there are others as well that could also have an impact on the trajectory of Apophis. And once again, How big of an impact? Well, very, very small, of course, but it's only going to take a very, very small change in trajectory to put Apophis on its current path where it misses us by about 20,000 kilometers to a collision course to where it creates a bigger explosion than has ever occurred on the surface of our planet in recorded history, and a huge impact to our planetary climate. And again, possible horrific horrific tsunamis. Just bad stuff indeed. Howie, thank you so much for your support. Graham D, thank you. Wow, we've suddenly had these awesome super chats flood in. Really appreciate it. And a big one too. 50 euros come hell or high water. No worry. We just hit the thing with the Boeing Starliner, so it's good to for something. That's a hell of an idea. I like that idea a lot. Let's go ahead and smack it with the Starliner and knock it out of a collision course. So once again, I don't want to sound like I'm being this alarmist. The sky is falling. Apophis is going to hit us, and end the world in 2029. That is not what I'm saying at all. Instead, what I'm saying is the odds of Apophis hitting us based on what we know right now are very, very low indeed. No matter what happens, it's very unlikely that Apophis is going to hit us in 2029, but not impossible. Not impossible. If we are ever talking about a close shave like this, any change in trajectory, even minor, could change everything about the danger that this asteroid presents to our planet. And so, what do we do? Do we start to panic? Do we start stockpiling food, and that? No, of course not. What we do is prepare for this eventuality, because even if Apophis is not on a collision course, some other asteroid in the future is going to be. So let's be ready sooner rather than later when it comes to this potential danger. Boy, we have a huge number of people watching, over 350 people. My God. Thanks very much for tuning in. Don't forget to like and subscribe, guys. Chris, thank you so much for the $20. Really appreciate all this incredible support I've been getting. So let's go ahead and have a quick look. I want to also let's see, there's also, right, the gravitational impulse. To be of concern, any change to Apophis's velocity would have to be to alter Apophis's trajectory substantially. The keyholes, yes, that's another thing. There's a gravitational keyhole that exists in close proximity to it's a very complicated thing, but it can oftentimes have a big impact on the trajectory of an object in space. And there is some concern that when Apophis makes that close approach in 2029, it's going to change its trajectory by passing through this gravitational keyhole phenomenon to where it will be on a collision course during its next approach. I am far less concerned about that, because if that does happen, we still have years to prepare for a potential collision in the future. I'm far more concerned about a 2029 encounter than I am about anything else. So let's talk a little bit more about these particles. If particles were being ejected from Xanthus by any mechanism, it is possible that Apophis could collide with this debris as the asteroids pass one another. Debris from Xanthus, if any, could pass closer to Apophis than Xanthus itself and could strike it. The impact of dust particles in the sub millimeter range is unlikely to have a substantial impact on Apophis's path, but the impact on Apophis of even a single 10-centimeter particle, such as seen at Bennu. So once again, we know that these particles exist in conjunction with larger asteroids. We know that these things can happen because we have seen them created during other observations of asteroids of a similar kind. So a 10-centimeter particle hitting at 11 kilometers per second with a typical asteroid density of 2,000 kilograms per cubic meter. So that's another thing to know. The average weight of an asteroid is approximately 2 metric tons per cubic kilogram, or per cubic meter rather, 2 metric tons per cubic meter. Very heavy indeed. And this would release 20 megajoules of kinetic energy if just a 10 centimeter piece of an asteroid were to hit. And by the way, there's no way for us to predict whether or not there's any of these 10 centimeter rocks lurking out there that might hit Apophis between now and 2029. If one of those were to hit, as I said, it would release the equivalent of 20 sticks of dynamite. 20 megajoules of kinetic energy, the equivalent of 20 sticks of dynamite. And such an event would certainly have effect on the impact probability with Apophis with Earth at a later date. Once again, I can't begin to understand. And the reason I keep reading these details is because I can't believe that the media is coming out and somehow reading this study and interpreting this information as saying that there's no chance whatsoever that Apophis is going to strike us. This study is instead saying, without question, that we don't know enough, that there are things that could definitely change the future trajectory of this dangerous near Earth object. And so, therefore, it requires further study. We need to learn more about the potential danger that this asteroid could represent, its journey through the solar system, the effect that other objects have on it, and not just Apophis, but every asteroid that theoretically could come into contact with the Earth. We need to understand all of these things and thoroughly. Hi, Q. Thank you for the $5. Apophis gets thrown. Yes, close. We could throw Starliner at it. Yes, it seems like we have a lot of people suggesting that. I think that's a great idea. It's about the only useful application for Starliner, in my opinion. All right, bear with me just a moment here. Let me go ahead and see if we have it before we close today. If there's anything else. Here we go. There's another asteroid. I did mention that there were other asteroids that could be a problem. Let's go ahead and talk about this one. Asteroid 2009 JG2 is 100 meters in diameter and was observed only briefly, 23 days in 2009. The reason for that, by the way, as I mentioned before, a lot of asteroids get lost in the glare of the sun. And so they're only visible for a small amount of time as they plot their course around the solar system. So they have theoretical collision possibilities with this asteroid. But once again, we can't be certain because we don't have near enough data about this asteroid. And like the Xanthus asteroid, it also will have a close approach with Apophis in late 2026. So very close to the same time. The uncertainty in its orbit has a big impact as to whether or not there's going to be an encounter. We really don't know enough. However, according to the statistics that they have up to this point, they're giving this asteroid a 2% chance of having a close approach with Apophis to where it could make a difference. 2%, that's not insignificant. That's actually a very significant chance compared to, other probabilities that we look at in the universe. So once again, they most probably, even if they do have a collision, or rather a close approach, they'll remain 8,000 to 9,000 kilometers apart. But again, same potential issues here. There could be debris traveling in close proximity to this asteroid. If any piece of it, 10 centimeters or larger, hits Apophis, it will change its trajectory. There's also the asteroid 2009. Let's see, did I mention that one? Yeah, I mentioned 2009 JG2. Are there any others? I know that there's at least a couple that come into close proximity to this asteroid. 2022 KN3. Also 2016 FB12. Now, those two asteroids, the other two that I have mentioned, they have been discovered far more recently. And again, don't have a great deal of information on where those asteroids are going. All we can do is make educated estimates on whether or not they are going to have close approaches with Apophis, but it is indeed possible that that might happen as well. So yeah, this study has been very intriguing to me. It's been very enlightening. It's revealed that as much as we think that we understand and that we have mastered the potential threat that near Earth objects represent to our planet, as much as we think we understand it, we really don't. Because even though we've spelled out a number of potential close encounters that may or may not change the course of Apophis, and the odds still remain very small that this asteroid is going to hit. This study does not take into account the possibility of objects that we haven't detected. And there's a great many of those making a close approach with Apophis as well. The vast majority of asteroids that are 100 meters or so in diameter have gone totally undetected. It is very possible that an asteroid this size or much, much smaller will eventually come into contact with Apophis between now and 2029 and tragically change its course. So once again, just to reiterate, am I, screaming that the sky is falling? Am I saying that we are on the verge of a, planet-wide catastrophe and that all you guys should go out and start buying guns, ammunition, emergency rations, et cetera, et cetera? No, absolutely not. Odds are 2029 is going to come and go with no collision whatsoever. The odds are very much in our favor. It is far more likely that we are going to have an amazing close encounter with an object that usually goes totally unnoticed in our skies, but Apophis will be visible with the naked eye. It will be that close to where we will be able to see it very clearly in the sky. I mean, keep in mind, this thing is passing us within the orbits of our geosynchronous satellites, and its size and albedo, it will be a very bright object in our skies. And if you have a telescope, you're going to be able to see a lot more than just that. So odds are this is just going to be a very exciting night in astronomy for all of us. But there's also that remote possibility that something is going to change Apophis's course between now and 2029 that could turn an amazing and fascinating night into a night of utter disaster. And that's something that we should just be prepared for. What should we do? We should have something like the DART mission keyed up and ready to go, ready to be fired on an interception course, and preferably maybe 2 or 3 of them, just in case we have some sort of an anomaly with the launch or something like that. Have a couple of them ready to go, and preferably not actually sitting on the ground, but actually in orbit or in lunar orbit, where the influence of gravity is not going to affect it that much, and it could go on an interception course far more easily and with less fuel. If we were to do all of that between now and 2029, I think we could say with a great degree of certainty that we are absolutely safe. But until we actually do that, we're not safe at all. Thank you very much for watching. Really, really appreciate everybody tuning in. Please don't forget to like and subscribe. Stay tuned. I'm returning home in a couple of days, and the Saxavord event is going to be something to remember, folks. And because of you, I'm going there. So thank you so much for all of that. Till next time, stay angry about space.